Welcome to this video on how to mainnet fork in Hardhat for testing your contract. As a blockchain developer, it's crucial to thoroughly test your smart contracts before deploying them to the Ethereum mainnet. In this video, we'll show you how to use Hardhat to create a mainnet fork for testing your contracts, which allows you to replicate the conditions of the mainnet without spending real Ether. To get started, you'll need to install the Hardhat npm package on your machine. Once you've installed Hardhat, you can create a new project with the npx hardhat command. By selecting Sample JavaScript Project, it will generate us a sample project, with a basic project structure with a hardhat.config.js file. Next, we need to install the dependencies specified in the terminal and we'll run the test file, to check that everything you'll need to configure Hardhat to connect to the Ethereum mainnet. This involves adding a network configuration to your hardhat.config.js file, specifying the URL of an Ethereum node running on the mainnet.
Don't worry, I will be also showing you a small demo of test cases too. We can also pin the block of the chain by specifying the block number, and Hardhat network also allows you to impersonate any address. This lets you send transactions from that account even if you don't have access to its private key. Let's take a look at the sample contract. So this is a simple vault contract that locks ETH for a specified amount of time, set while deploying. With a single withdraw function to withdraw the locked ETH and with simple validations, so it can be withdrawn only by the owner after the unlock time. The contract also imports Hardhat console for debugging, but there is no console over the contract, only the one which is commented, which lets you know the current time and the unlock time. Moving over to the test cases, there are lots of tests written here to validate the contract and make sure it performs exactly as expected. So the important thing here in the test file is this load fixture in time. The load fixture allows us to reuse the instance specified in the function, where the time is used to skip or get to the certain block time, so we can validate thing more precisely. There are different described block here for each validation scenario, and it blocks for each validation. I will be adding some more lines here to show you how to impersonate the signer and to use the instance of the already deployed contract. To impersonate the signer, all we need is the public address, and by passing the address in the getImpersonateSigner function, we can use it as a signer. Instance of already deployed contract, we will be needing the address of the contract and its ABI. ABI is an interface of the contract in JSON format in order to interact with the EVM bytecode, which has all the functions, events, and state variables in it. So it's not necessary that we need the whole ABI of it. We can also specify the ABI in this way by only having the names of the functions that we need of the contract. Hardhat also have local node in it which can be run by npx hardhat node command, so we can use this node to also test our frontend or the script, which also exposed to in JSON RPC, that is used to connect to an external applications or your MetaMask wallet. That's a brief overview of Hardhat. If you're interested in learning more, I'll leave some links in the description to some resources that you can check out. Thanks for watching, and I'll see you in the next video.